Okay, so yesterday we talked about atoms, and it turns out that atoms can make bonds. We talked about these things called biomolecules. If things are too messy, or if I'm going too fast, or if you don't understand something, please raise your hand and say, I don't understand this. But everyone should be facing forward, because I'm writing on the board. How could you possibly know what's going on if you're not facing forward? So biomolecules. If something's too messy, please say something. Say so. We'll rewrite it. If you can't read it, not close enough, or what have you. The word biomolecules has this word molecule in it, right? Bio means life, and molecule means more than one atom bound together. But what does it mean to be a molecule? What does it mean to be a molecule? What kinds of interactions do atoms have? So to understand it is to go in, it would mean, to really understand it, you probably need a chemistry, at least 2 or 3 months worth of chemistry. And so we don't have that. So I'm going to give you an outline of what it is for atoms to make a bond. I think it's enough. In years past, students say they understood what was going on. When you get to chemistry, you're going to have to calculate some things. You're going to have to decide where the electrons are. You're going to have to make all kinds of decisions, right? But I'm going to make it as simple as I can, all right? So let's look at the simplest atom, hydrogen. How many protons does hydrogen have? You have your periodic tables. One. That's one proton. And where would you find that on the periodic table if you wanted to know? It's atomic number, right? The atomic that's at the top. It's a whole number. The number of protons is also always whole. You never have half a proton or 0.3 of a proton. Does that make sense? So your atomic number is always whole. Hydrogen is atomic number 1. Helium is atomic number of 2. Lithium is an atomic number of 3. Now, if you were going to draw hydrogen, you would put a proton. Hydrogen is, what's the mass? So that's atomic number. What's the mass number? Now you're going to have to not only look at the periodic table, actually read the key. Go ahead and read it. Look at your periodic table and read it. What's the mass number for each of these? You always have a periodic table in this class for a test, if I'm asking you these questions. The answer is on the table. What is it for hydrogen? 1.008. Very good. For helium, what is it? That's He. 4 point what? 4.0026. 0026. And lithium? 6.94. All right. Now, these mass numbers are atomic mass units. Now, based on what we said yesterday, if you think about what we said yesterday, I'm not going to repeat it because I want you to think about it. You can look at your notes. What determines the mass of an atom? Say it.
The protons.
The protons is 1, right? So protons, and what else?
Neutrons.
That's right. The protons and the neutrons. Why not the electrons? Because they're negligible. They're really tiny, so we can ignore them. So only 2 things are going to make up these numbers. The protons plus the neutrons. That's it. Now, I told you can't have a fraction of a proton, and you can't have a fraction of a neutron. If you break a proton and neutron up, all kinds of things happen. That's not chemistry, that's nuclear physics, all right? That you're dealing with atomic reactions, right? Radioactivity, and etc. What we're talking about here is chemistry, the stuff that happens every day around us. Yeah. The mass of an atom is equal to the protons plus the neutrons. Does that make sense? So that's it. Now, but then I told you something else. I told you you can't have a partial proton or a partial neutron. You can't break them up. You either got a proton or you don't. You have a neutron or you don't. So how do I get decimals here? It's a good question. It's a really good answer that you just said. It's not right, but it's a good answer. He said electrons. It could be electrons because electrons are a fraction of a proton. So you're absolutely right. It might have been, but it's not. And so good answer. But the answer is a little. It's obvious, but it's a little weird. It's the average of all the different kinds of atoms. And we'll talk about that in a minute. Now let's round off this number. What would you round this number to? 1. I'd round it to 1 as well. So I'm gonna put the rounded number in parentheses. 1. What's the rounded number for helium? 4. And the rounded number for lithium? 7. So the most common form of hydrogen has how many protons? 1. We know it has 1. How many neutrons? 1. If it had 1 proton and 1 neutron, what would be its mass number? 2. What's the mass number? 1. So how many neutrons does it have? 0. So hydrogen's atom only has a proton. That's it. That's hydrogen. I'm just going to kind of draw them over here if that's okay. I wish I would have given this is why I tell you, make sure you give yourself enough space. And this I did not draw enough space for myself. So I'm going to do a trick. I'm going to do that. Is that okay with you that I did that? Does that make sense? All right. So 1 proton. Now what about helium? 2 what? Speak up. I hear the right answer, but I need to hear it. 2 protons and 2 neutrons. How do you know it has 2 protons?
It's the atomic number.
It's the atomic number. Very good. So there's 2 protons and 2 neutrons. And what about lithium?
4.
3 protons is right. And 4 neutrons. Those are the nuclei of these atoms. Now that becomes important because not every lithium has 4 neutrons. There might be a lithium out there with 7 neutrons. But what happens to it really quickly? Say what? It goes down. It breaks apart. They become unstable. Anything that's not around any lithium, most lithiums have 4 neutrons and 3 protons, right? Because that's the most stable. That's the one we see. The ones we don't see break apart really quickly. They're called radiation. They're radioactive. They break apart, and they're no longer lithium. Same with helium and hydrogen. There are hydrogens out there with a neutron. Well, when you have a proton with a neutron and a hydrogen with a neutron, it breaks apart. It's radioactive. Is that clear to everybody? All right. So these elements that are radioactive are rare. The reason they're rare is they break apart. That's what makes them radioactive. So that's why there's an average. So all the different kinds of hydrogen, the average is 1.008 because most of them are 1. No neutron. The same with helium and the same with lithium. Are we clear on that? So those are the nuclei. Now that's going to become important when we talk about radioactive decay. That's going to become important when we talk about radioactive isotope dating. All right, we start dating fossils. So that's not till next semester, but you need to keep in mind that that's there, okay? Oops. So now, that's great. That doesn't really have a lot to do, though, that does not have a lot to do with chemistry. That has to do with the nucleus. It turns out that the chemistry, that tells us the mass number. By the way, on ACT, I've seen on ACT questions, I've seen on, I don't know about end of course questions, I don't look at those tests, but I've seen on different standardized exams where they will tell you, look, you have an atom that has a mass number of 20. And it has AMU. And it has 10 neutrons. What element is it? What element is it? It has a mass number of 20, it has 10 neutrons. What's the element? Why did you say calcium? Mass number 20. How do you know what element? How do you know what determines the element? It's atomic number. Do you see the atomic number in this? Are these either one of these atomic number? What do you think the atomic number is? You think the atomic number is 10. That's correct. How does he know the atomic number is 10? That's perfect. Did you hear him? Because he gave you the perfect answer. Could you say it loudly, please, so everybody, these guys over here can hear it? Because he's absolutely right. Go ahead and say it.
If it had an atomic or a mass of 20, and it had 10 neutrons in the other part of the mass, that have to be protons.
All right? Because the protons plus the neutrons is the mass number. If you had 20, this number here is 20. So can we do some algebra? You want to do some algebra real quick? Yeah, it is algebra. So let's do the algebra. It's really easy. It's an easy algebra, right? So if the protons plus the neutrons, right, equals the mass number, right? And I told you mass number is 20, and I told you neutron number is 10, what does that leave you? Right, minus 10 on each side. So the proton number equals 10. You see? Algebra.
So it's neon.
So what is it?
Neon.
Neon. How did she know it's neon? She looked at a periodic table, looked at the atomic number 10. So you can see these kinds of questions. Will I ask you these kinds of questions in biology? This is something that people want to know. Probably not, to be honest, because we don't have time. This is stuff though that you might see in Mr. Custer's class. All right, you might see this when he covers this in class. He will probably ask you these questions on his quizzes and his tests. They might ask you this on the state exam. They might ask you this on the SAT. If you take the science portion, they might ask you to do this on an ACT. You certainly will see it in AP Biology or Physics, AP Physics. For sure. This is stuff that kids should be able to do. But we got some more detailed things to do. So let's look at this detailed stuff. We have these things called electrons, right? I told you the electrons are what are important for bonding. So let's take a look at that. So if we take a look at hydrogen again, our little atom has how many protons? Plus one, just one little proton. So I'm just going to draw the proton here. There it is. There's two basic rules. Two basic rules that you have to follow, and if you follow them, honestly, all of chemistry, most of basic chemistry is based on it. And here are the two rules. All right, atoms and molecules favor a neutral charge. All right? Atoms and molecules favor neutral. Energetically speaking, they are more stable when they are neutral. I used to say they like to be neutral, they want to be neutral, but kids get all confused. So they want to be neutral. What is neutral? That means a zero charge. If I have a +1, how do I get 0? Subtract 1. I need a negative. If I have a +1, I need 1 negative to get 0. So how many electrons do you think hydrogen normally has?
1.
1 electron. That's the normal zero charge hydrogen. But there's a second rule. That's only one of the rules, right? There's 2 rules. It's just 2 simple rules. They favor atoms and molecules. Let's just say atoms. Favor a full outer shell. Now, if this is an atom, this is an outer shell. I am not going to go into, I used to have you guys as ninth grade biology students go through and fill in all the electrons and do the up arrow, down arrow, and talk about orbitals and hybrid orbitals, and kids would just balk. Their little heads exploded. After the 5th kid's head exploded, I said, okay, let's stop that. So the first 2 elements, hydrogen and helium, they only need 2 electrons in their outer shell. This is their outer shell. They only need 2 electrons to be full. That's all you need to know. So hydrogen just wants 2 electrons. So how is this hydrogen going to get 2 electrons in its outer shell? Let's say it comes up and meets a second hydrogen. Let's say these 2 hydrogens. Here's a hydrogen. It has an electron. Here's a hydrogen. It has his electron or her. These 2 are sitting there. How is it that these 2 atoms can get 2 electrons around them?
Connect.
They connect. They share. They share. They share these electrons. What does it mean? How many electrons does this atom have?
2.
How many does this atom have?
2.
Now, a lot of kids, they don't understand sharing. So they say if this guy has 2, then the other one has nothing. Right? But that's not sharing. Sharing means you both have it. Does that make sense? So another way to draw this, if I were going to draw it, again, and make it simpler, because nobody wants to do all this drawing with circles and ellipses and etc., right? So what we draw is H, line, H. What is the line? What is the line? It's 2 what? 2 dots. The connection 2 dots, right? Two points define a line. You remember learning that? All right, on a graph anyways. So this line represents the 2 electrons that are connecting it. Each one of them gets 2, so this is stable. Another way of drawing this would be to do this. If you see H2, what is it? Hydrogen, and it's a gas. Just so you know, hydrogen gas. You will be making this in class on Friday. Hydrogen gas. So that's hydrogen. So that seems easy enough, right? Okay. Now this is called by this sharing is called covalent bonding. Covalent bonding. These 2 share those electrons, everybody's happy. These 2 atoms are both happy. What's this called? What is sharing electrons called?
Say that again.
Covalent bonding is correct. You just read it off the board though. All right, so anyways, so covalent bonding. So that's the sharing of electrons. Now, there's something else that can happen. Is you can get a little, now these two are they're the same, right? These two are about the same size. It's like any one of you ninth graders coming up with another ninth grader, and you're going to share your money because you have no choice. If you want to buy a cake that costs you $100 and you each have 50, you're each going to pitch in 50 so you can buy the cake, right? So you can share it. But what happens is that you got your bullies, right? You got your seniors. You got the gangsters. The rice and beans, there you go. Now this can go on YouTube, don't get me beat up. It's my neighborhood, all right? And back off. All right, so chlorine. Chlorine's one of these, look on the right-hand side of your periodic table. Right-hand side of your periodic table. These elements, again, I used to go through this in detail. Do you see where it says at the top, the Roman numeral 7?
What?
At the top, it says Roman numeral 7. At the top of the column. You see how they have Roman numerals? Do you see where 7A specifically?
Oh, I see it.
All right, at the top, 7A, no, those are letters. But there's 7A, and there's 1B, 2B, 7B. But look at 7A. All of those are very close to 8. Every element, except for hydrogen and lithium, they want two electrons in their outer shell. They want I'm sorry, I reversed that. Hydrogen and helium only want 2. Everyone else wants 8. 8 electrons in their outer shell. Is that clear?
Yep.
It's not really true, but close enough. Almost every element on the periodic table wants 8 electrons in the outer shell. The top number, that number at the top, look at me carefully and listen to me. I'm not talking about these transition metals. That's these things in the middle. I'm talking about everything else. On the right-hand side, starting from boron, the B, all the way down over to the right where it says neon, Ne. Do you see that? All the elements on that side of the periodic table, all of them take electrons. All of them will share or take electrons, especially the last 6 and 7, especially 6 and 7, those two columns. And the ones we have to worry about are chlorine, oxygen, and sulfur. They love to take electrons. They're what we call highly electronegative. So chlorine is one of those bullies. It takes electrons. How many electrons does it have in the outer shell? It's the Roman numeral at the top of the column. How many does it have? 7. So I'm going to draw 7 here. How many does it need? How many does it want? It wants 8. Just needs 1 electron. That's all this thing needs, is 1 electron. Now it comes along and meets this hydrogen that has 1 electron. Now this thing is a bully. It's big. All the 6 and the 7s, they're bullies. They're going to take what they want. It's not going to share with hydrogen. It will not share. What do you think happens?
Take it.
It takes it. It's going to take that electron.
What do? Swallow it?
Watch. What's going to happen, it's a good question, is it takes that electron, it pulls it in, and just takes it, rips it off the hydrogen. Then what you get left with in the end, and I'm going to put this is called yields. It means you start with this, and you're going to end up with what you see on this side. This is something that's called yields. All right, so yields what comes next. So when that happens, you're left with hydrogen that's missing an electron. Does it have a charge?
Positive.
It has a positive charge. Good. It has a +1 charge. The chlorine now has how many electrons? 8. It had 7. It was neutral. Now it has an extra electron. What charge does it have now? That's right. Somebody said -1. So it's one negative charge. Why? Because it took the extra electron. It took this electron from hydrogen. When it took that electron from hydrogen, it became negative because it has an extra electron. It was 0, but now it has an extra electron. So it became negative. It's happy because rule number 2 is fulfilled. But it's still not perfectly happy because what about this one? It's not neutral. So they hang out with each other. This is called, we call it an ionic bond. They're associated. They're not really sharing. It takes it. But we call it an ionic bond. This happens a lot. I'm going to give you a couple more examples. Another bully called chlorine. Again, chlorine. Oh, I put carbon here. I'm sorry. That's chlorine, Cl. So chlorine then can meet up with sodium. Now on the right, how many electrons does sodium have in its outer shell? Look, where are you looking on the periodic table?
You got 11.
Look, okay, you're right. It has 11 electrons total. You're right. But how many electrons does it have in its outer shell? You have to look at the top of the column. 1, right? It has 1. Does that make sense to everybody? You're looking at the top of the column. Not the middle, not the elements in the middle. That's a little more difficult to discuss. But the ones on the right have either 1 or 2. The ones on the left have anywhere from 3, 4, 5, 6, or 7, or 8. There's 8. So this has 1, 2, 3, 4, 5, 6, 7, 8. 7. Sorry. What's going to happen? It's going to steal it. Chlorine's going to take it. And what happens is that you get what? What's going to happen? What are you going to get? Sodium what? Positive, because it's missing an electron. And chlorine what?
-1.
-1. That's sodium chloride. That's salt, table salt. You eat it all the time. When you put it in water, that's why it's going to turn into ions. These are called ions. When an atom is charged, we call it an ion. So these are ions. This is an ion. That's an ion. That's an ion. Any of these atoms that have a charge, we call it an ion. It's just sodium. It's just hydrogen. It's just chlorine. But it's them with a charge. The electrons are not balanced. We call this an ionic bond. It's different from sharing. When you're sharing, they're both equally strong. Nobody's bullying anybody. They're sharing the electrons. There's no charge. Notice that there's no charge. That's why these guys end up being gases, usually. These end up, the things with ionic bonds tend to be liquids or solids. Why? Because what's this positive charge going to do to the negative charge? What does positive do to negative? They cancel each other out, so it'll be 0. But what do they do to each other? What does the positive side of a magnet do to the negative side of the magnet? They attract. They attract. So they pull towards each other. They're stuck to each other. You want extra credit? I'll give you 1/3 of a quiz score if you do this. I'm about to tell you. You go home. You get a balloon. It's a lot. It's some work. You might have to go and spend a whole $1 or something. But get a balloon. Fill it up. Tie it off. Take some table salt. Ask permission from your mother first, or father or guardian. I don't want you causing a mess and then their mom's calling me, telling me that you made a mess in the kitchen. Put the table salt on a plate. Take your balloon and find something that's wool. A sweater, carpet. You can use your hair as long as it's not full of gel. And rub the balloon on. Rub your balloon on your head. You're collecting electrons at that point. You're making the outside of the balloon negative. Then go and move it towards the salt. Don't touch the salt. Move it near the salt. And videotape this, so I want to see it happen, so I need evidence that you did it. If you do that, I will give you half a quiz score.
At first you said a third, now you saying half, okay?
Did I say a third? I
You
said a third.
half. No,
I said a third.
The last
I'll
one you
rewind
said
it.
a
I'll
half.
rewind the tape.
But the last time you said a half.
Yeah, so it's a half.
I like how this is. You should be a lawyer. All right, so we'll go with half a quiz score.
Y'all are what?
Yes, sir.
You have to do that. Now, here's something else you can do for fun if you want. It's not really directly related to this. So, if you take a pie pan, a tin pie pan, do the same thing with the balloon, same balloon. Move it near the pie pan and see what happens. Move it slow. You can record that too. Do it slow, and if the lights are off, you'll really see it. You'll see.
I'm dead.
Has anybody done this at all? Ever?
The balloon, yeah. I did a balloon, but I ain't did that.
You'll have fun. You will have fun doing it, I think. And if you have a little brother and sister, make sure they're in the room with you. It's safe. It's safe. So again, let's review the procedure. You fill up the balloon, rub it on something that doesn't have oil on it. Rub it on it really nice. The more you rub it, the stronger it's going to be. Put the salt on a plate. Honestly, the best thing is to put the salt on a black piece of something, and not plastic, because something else will happen. You want it on like a black piece of paper or something, or a black table, because you can see the salt clearly. If you look real close at the salt, what you're going to see is little cubes. The salt are made of little cubes. That's because what happens is the sodium gets surrounded by a chlorine, sodium, chlorine, sodium. Do you see what's going to happen? They ultimately end up making a cube because of the way they're ionically binding. They're making a matrix. So you have all these charges. You can imagine, you could go ahead and make a hypothesis and think, what do you think is going to happen when you move that balloon near that salt? Don't tell me. I don't want to know. Go ahead. You can make your guesses on videotape before you actually do it. Anybody that does all the hypotheses and everything and does a good video, if you do a good enough video for me to share with everyone else, you don't have to show your face. You don't have to be embarrassed. If you do a video good enough for me to share with everyone else, I'll give you a whole quiz score. All right? Fair? All right. Say again?
Can you send us the instructions on Google Drive?
I'll post this. Is that fair? I would just send you the instructions. The issue is I have to go right after school today. I have to go to the Cleveland Clinic to go pick up a bunch of lab equipment for you, but I don't know how long it's going to take, and so I don't want to promise you I'm going to do anything like that. But at lunch, right after you leave, I can upload this to YouTube, and you guys can access it there.
What's the YouTube channel name?
My name,
Your name?
yeah, Manuel Mendoza, yeah.
Okay,
Man,
what's gonna happen if you use plastic?
You can go ahead and do it, see what happens. Is
Is it gonna be like, is my mama
It's gonna
gonna
burn the
get
plastic.
right?
Just do it with your mama. Your mama might enjoy it. Would I tell you to do something that's dangerous?
She said maybe.
Just don't. And then if you want, you can do it later. But if you're gonna do it initially, don't, because it's good. Why are people putting things away? I still got 5 minutes. All right? Isn't this class over in 5 minutes?
10:45. 44.
When is the class over? Look,
10:54.
10:54. I got 5 minutes.
4 minutes.
Now I got 4 minutes after you argue with me about having 5 minutes. All right, so that's really what it comes down to. Wait, I want to wrap this up, okay? Let's wrap it up. So there's those two concerns. You got, look at what I'm doing. I keep doing this Cornell stuff here because I expect you to be doing it on your notes. And I think somebody in the back's gonna have to move up to the front, because I need to see that you're actually participating. So we said there's 2 rules. You need to know your rules for electrons. Let's call it for bonding. There's 2 kinds of bonds. There's covalent and there's ionic. Is this neat enough? Is this clear enough? I didn't go too fast? All right. Ionic, and the summary here is I need to know the different kinds of atoms, ions, and not, and let's put that up here too, ions, and the different kinds of bonds. And what do we what's the topic? What's the title? Chemical bonds. And of course my name, period, date. I'm reminding you because when I grade notebooks, people are going to lose points because they don't put their headers on their papers. I'm doing it. I'm doing this because I'm trying to model it for you. And of course, I would put pages on it. I would put page 5 of 5. And I can't tell you when in college and in medical school how useful it was when your papers fall out on the floor and you have to remember what, instead of looking at a date and trying to put things together by date, you have page numbers. Wow, it's so easy. Yeah. Where?
I was thinking.
This thing here?
Yeah, that.
That's an and. It's just a quick way of writing and. I do shorthand. When I take notes, I do shorthand. Instead of writing the word and, I put that little symbol. Instead of putting different, I'll put diff. It saves time. You know, one of the things that somebody said yesterday to me as kind of feedback is I find it hard to keep up with the notes. I'm writing stuff and you're going on to the next thing. But that's because you're trying to write out the whole word. You're worried about spelling. You're worried about punctuation. These are notes. This isn't a paper. So you need to, as long as you can read it, you know what the meaning is, and it's clear. Instead of writing add, just put a plus sign. Yeah. They're here on the board in the notes. I'll upload them now. Yeah. The what? The summary reads, I need to know the different kinds of atoms, ions and not, and the different bond types, the different kinds of bonds.
One more class too.
No. When do I give homework? This is.
You really get homework.
I give you projects that you have to get done, but it's a lot. It's work. The main thing. Oh, on your way out, I need your contracts because I need to go through see who has them, who doesn't. Hand them to me on your way out. Thank you. Thank you.
I don't know why I have 3, but they're all.
This is not signed. Whose is this? Tariq, you have to have this signed at the back. Sign it and have your parents sign it by Friday.
See about Friday?
By Friday, that's the day of the lab.
Okay.
Thank you.
Is that
Thank
how
you.
you spell ibuprofen?
Yep, that's good for me. Amoxicillin and ibuprofen? Do you take, what do you take, aspirin when you get a headache? Oh, no, you have to take Tylenol. Yeah, that's right. Acetaminophen. Well, I'm not going to give you either one of those, so I don't have to worry about it.
why.
Although, if we did a bacterial, if we're doing bacteria, like growing bacteria on a plate, and I'm using amoxicillin, are you allergic? You have to be careful. So you have to remind me that if you see that word amoxicillin, remind me that you're allergic. Because there is an experiment, I don't know if we'll get to it this year, but where we grow bacteria on a plate, and one plate has an antibiotic and the other plate doesn't.
Okay, I have a question.
Yeah.
Okay, so I actually learned this stuff last year.
Which stuff?
Like what we're doing now, like with the covalent ionic bond.
Oh, good. So you're having
We had
to
to turn this
Yeah.
in today.
hold on. That wasn't collected. That's for you to review. That's not due till September 10th. Yeah.
Okay. But I just want to make sure like what we do in this class won't be like a repeat of like what I did at my old school, like you know.
Oh, I don't think it will be.
You know.
Did you look at the biomolecules? What I
No.
handed out to you? You've not looked at it?
Oh yeah, yeah,
You looked at it?
yeah.
And that's all, you covered all that?
Not all of it, but like a lot of it.
Did you?
Yeah.
I don't think, we'll see.
Okay.
We'll see.
Okay.
But this is only going on till September 10th. Then we're gonna use this to move on.
Okay.
So, this is what we're talking about now, what you covered in middle school, we'll be done with at the end of the
Well,
week.
yeah, I'm sophomore. So,
Oh, I see.
yeah.
I'm sorry,
It's okay.
I'm used to ninth graders. When you're done, what you covered last in chemistry is gonna do you very well in this class.
Okay.
So you'll be using it. So use this as a time to review.
Okay.
And when we move on and start to talk about how these things interact, polar, non-polar, what crosses the cell membrane, what doesn't cross the cell membrane, how fast does it cross, how do you make ATP, what's photosynthesis, what's cellular respiration, you're gonna be ahead of the game when we get there. But it will not, I believe it will be neo, unless, I can't imagine you cover that in chemistry.
Yeah.
All right, you good?
Are we gonna learn how to combine elements?
We're doing it tomorrow, on Friday.
Alright, I learned that in 7th grade.
Yeah,
Do we have to use the front and the back one, or can I just staple these?
you can staple them in.
Is this what you was talking about today? Because
That's Cornell's, yeah, it's it.
Because I'm talking about like the thing, cause I like watched your video like Sunday.
Oh, that's nice, very good.
Was that what you was talking about?
The electrons moving, that's what I was talking about when we talked about iron and oxygen, yeah. Those electrons moving around. That's good that you made that connection. That's exactly right.
Okay.
All right, kiddo, have a good one.